we can use the chain rule for partial derivatives as well. So let's just do a bit of a recall of what we've done in previous work. If you've got y equals sine of 2x squared plus 1, we can say, to make this simpler to differentiate, and we want to find dy dx obviously, we can say let u equals this bracket, and so du dx, derivative of this with respect to x is just 4x. And so therefore we can say y equals the sine of, instead of that bracket, we can say that's u. So we can go dy du is equal to derivative of sine is just cos. So we know from the chain rule that dy dx is dy du times du dx. And one way to remember that is, even though you can't do it, but these can't cancel each other out, and so you get dy dx, these cancel out, 1 and 1, you'll get dy dx equals dy dx. So that's the way I remember it. We now do the substitution in. What was dy du? Dy du was cos of u, and du dx was 4x. Now we've got to do the back substitution because we've got to give everything in terms of x. Bring the 4x to the front, it looks a bit nicer like that. And the cos, now instead of that u, we did the substitution u equals 2x squared plus 1. Alright, so that's what we've done in the past, where we've got y as a function of x, so one variable. So let's look at now how to do partial derivatives using the chain rule. So if we've got f of xy equals sine of x plus y squared. So my function now is in terms of two variables, x and y. And we can say that's equal to z. And we want to find partial derivative of z with respect to x. We use the same process as we did up here. So we'll let u equals the bracket, x plus y squared. So partial du, and we want with respect to x, is equal to partial derivative with respect to x means that y is constant, and derivative of x with respect to x is just equal to 1. And so we've got z equals sine of u. So partial derivative of z with respect to u is equal to cos u. So now we can go partial z with respect to x is equal to, using the chain rule like we did up here, will be partial z, always start with the top one there, and we've found with respect to u times, what was the other one? Partial u with respect to x. So once again, it's like the partial du's would cancel out 1 and 1, and you get partial dz dx, partial dz dx. And what is that equal to? We do our substitution in now. Partial z with respect to u is equal to cos u times partial du dx is equal to 1, and that'll be equal to cos, instead of u, we did the substitution, u is equal to x plus y squared. Likewise, we could actually do, if we were asked to find partial dz dy, so we'd once again let u equals x plus y squared, and so partial du, now we want with respect to y now. And if we're going to do this, x is regarded with respect to y, x is going to be a constant, so the derivative of a constant is 0, and the derivative of y squared with respect to y is equal to 2y. And we've got z equals sine of u, so partial dz du will be equal to cos of u. So quoting the chain rule, we want partial dz dy will be partial, you always start with this one, partial dz du times partial du dy, and do a check, they will cancel and you get dz dy, dz dy, yep, that's good. So dz du is equal to cos of u, and partial du dy is equal to 2y, and do our back, put that in the front, 2y, and then cos, do the back substitution for u, x plus y squared, and put that in brackets because it's the cos of all of that. Alright, so that's using the chain rule for finding partial derivatives.